Hi everyone, it's Rob from Innon here, and in this video I'd like to introduce you to a product line we do called Link.io. So let's see what we've got. So first up is the IO20. This is like the master module. This talks to your BMS using RS485 IP, and it has BACnet and or Modbus options, and it has 20 points on board. Now you can hook up to this master module, this IO20 module, expansion modules. There's only one in the range, but it's called an IO16, but you can have 10 of these. Okay, so they've got 16 points on them, and you can have 10, so you add them all together, you can have 180 points off of one of these IO20s in total. Now you'll notice on the IO20 it's got a little keypad which we'll have a look at later. So you can use that to pre-commission it, configure it, monitor it as a user if you like. But there's another way of doing that. You can hook up to it, this optional, it is optional, you can do everything from this screen, this optional display. Now you'll notice that it's got sort of buttons, dedicated buttons. It's a lot nicer to use. You can hook it up to this through a connector on the IO20 and have a cable, so you can work outside the panel as a commissioning engineer in relative comfort and safety if you like. Also you can add it to the panel door if you like, so users can use it and view IO readings and make overrides and things like that. So it's just another option for you. Okay, with that said, let's talk a little bit about how Link.io is different from maybe other IO module options that maybe we sell or other people sell. So the first thing I'd say is, yeah, the eagle eye of you out there might have noticed this little red oval. That is indeed the Corel logo. So this is made by Corel on behalf of us. We put our little app, which we develop and maintain, and we add features to from time to time. But basically, yeah, so we give a 5-year warranty on this, but also, as I said, Corel make this, and I think that gives you a lot of confidence in that, as I'm sure you know, Corel do a lot of OEM work with AC unit manufacturers, chiller manufacturers, and of course these bits of HVAC plant are put into critical environments like data centres. So the OEMs would definitely not use Corel unless they had a lot of confidence and a good relationship with them. So we're building on that, and that gives us confidence, which in turn I think should give you confidence. So that's a really good thing. Now, if you look at these modules, you'll see they're sort of multi-tiered with the IOs and the comms options at the top here. It's a very compact little unit to get 20 points into that, same with the 16s. So you get a lot of points for your footprint in your panel. Could be useful for things like retail, things like that, where they really want you to put a little panel in a little tucked away place. They haven't got room for big panels and things like that. So retail jobs and things like that, these could come in handy space-wise. Let's talk about engineering and commissioning these units. I think there's some good advantages to that. So as we said, it's got a little display panel, or you can hook this up. And this makes it easy to pre-commission and maybe use to test in a panel. If you built it into a panel, you can use this display screen to override outputs to, you know, see if control circuits are working, see if valves are positioning, and you can read the inputs. So you could sort of exercise and warm inputs up and things like that and observe the results here. So you don't need a laptop. A pre-commissioning engineer could use this display panel to do his job, and so could a panel maker to test the panel. Okay, so in terms of engineering this product, configuring the I/O and whatnot, you could do it on the display panel or this little additional panel, but there's a much better way of doing that. We've got something called a web configurator. You can access that from our website. There's a link to it on our product pages. And when you go in there, it's just a much more convenient way of setting this up. At the end of it, when you're happy with what you've done, you can produce a configuration file, and you can take that out, put it onto a USB stick or email it to your engineer. He could put it on a USB stick. And there's a little micro USB port in here, and you can use a little converter, plug it into there and squirt the file down, and it's all configured for him, and then he can start doing his pre-commissioning work. So that saves messing around on site trying to use a little keypad. So the last thing to say is that it's got a built-in watchdog. So as we said before in other videos, that's a great thing to have in a critical environment where if you were to lose the BMS for whatever reason, a comms problem or any hardware failure or firmware or software failure, basically you can configure the outputs on this as required to maybe run a couple of chillers and a set of pumps to keep your critical chilled water system running, say in your data center. So that's a very useful feature. Okay, well I hope that's of interest to you, and if it is, stick around because we're going to go over to the bench now and have a closer look at the hardware. So let's have a little look at how Link I/O fits in with a system that maybe you've got in a panel or something like that. So here we have the BMS side of things. Here we're using a JACE. It's talking Modbus TCP. It's going through a switch here that we've got the IO20 linked to. Remember we said the IO20 is like the heart of the system, so to speak. So this manages all the data requests and commands coming from the BMS to the whole system. So the Link IO20 is then linked on a field bus network. This is different from the Modbus and maybe MSTP, BACnet MSTP. Then it talks to the expansion modules. Remember we said we can have up to 10 of them. I'm only using one here through this bus here. There's a set of dip switches on the Link IO down here. This sets the address of each one and the baud rate, which our manual tells you how to set that. Okay. So you'll also notice, as we said, there is the keypad built into the Link IO20, but there's also the optional keypad, the more sort of substantial keypad, and this works in exactly the same way. And you can get to all the options, all the menus, and do all the settings exactly the same as this, but you might have this on the panel door or mounted outside the panel for your commissioning engineer. So mounting wise, as you can see, this is mounted on a DIN rail. That's how you mount it. Power wise, you've got two options here. You can have 24 volt AC, or as I'm using here, you can have 28 to 36 volt DC. So you've got to be a little bit careful here. And what's actually happening on my test rig here is I've got a power brick that's 30 volt. It comes into a converter, and that converter is just providing 24 volt for the JACE. So if you've got things like JACEs and maybe trend controllers and things like that using 24 DC, you need to consider a different option for your Link IO system. Okay, so as we said, we've got a master here. We're using a JACE. You could use something like an IQ4 integration, anything that talks Modbus or BACnet over RS485. So it could be Modbus RTU or BACnet MSTP. Anything that's capable of that can do it. So like I say, I'm using Modbus TCP over Ethernet. If I was using the RS485 version, there'd be an RS485 connector here, and I could connect it to my JACE using one of these ports here. So let's talk about the inputs then. So let's just move this out of the way a little bit. Let's start off with the Link IO20. Let's start at the bottom here. So we've got the universal input-output section here. We've got 10 of them. What can we do there? So these can be set to digital inputs or pulse inputs. You could use all 10 for that if you like. As far as analog inputs are concerned, we could use passive inputs such as thermistors or resistive inputs like potentiometers, things like that. There is a limitation if you use PT100 free-wire detectors. There's a limit of 5, and the reason for that is if you use one channel as a PT100 free wire, you must set the next one to not use. That's just a limitation, so you can have 5 maximum there. You must take that into account if that's what you're doing. So active inputs, you can have 0 to 10 volt, as many as you like. If you use 0 to 5, there is a 5 volt reference here you'll see on the IO20. And that can be used to go through something like a potentiometer to vary a 0 to 5 volt signal. If you use that 5 volt reference, you have a limit of 2 maximum 0 to 5 volt inputs, so you need to take that into account. 0 or 4 to 20 milliamp, there's another limit on there. You can have a maximum of 4, so you need to take that into account when you're pricing up jobs and project engineering your panels and things like that. So these universals can be used as outputs as well, and they can be used as 0 to 10 volt, or they can be used pulse width modulation at 100 hertz or 2 kilohertz. Moving up to the top here, we've got a set of relay or digital outputs. The first 5 have just got a common and normally open contact, and they can handle up to 5 amps. The 6th one here, that has got common, normally open, normally closed contacts, so it's changeover type relay, but that only does 1 amp. Now, everything I've said about the IO20 so far applies to all the IOs on the IO16. They work in exactly the same way, exactly the same limitations. But now I'm going to go on and describe the additional points we've got on the IO20, which are these ones down here. You've got 2 digital inputs. They're not pulse counting, they're purely digital input. And you've got a couple of 2 analog outputs. They can be 0 to 10 volt, pulse width modulation, 100 hertz or 2 kilohertz, the same as the universal outputs that we got down here. So as we said, we've got the optional display here, and that, as you can see, it just hooks into the IO20 up the top here on this set of terminals here. Okay, so that's basically the hardware layout and the different options on the inputs. So let's go and have a look and see how we can use the keypad to configure and view points and things like that. Okay, so let's see how the keypad works. Now, we've obviously got a few navigation buttons and things like that. This button here is the main menu button. It will always take you back to this menu no matter where you are. You click that and you go back to this main menu. You've got navigation keys that go up and down, so on and so forth. Selection, enter key there, and there's an alarm view key here. So let's log in. If I go back to the main screen, let's go into the auto manual settings. It will ask me to log in. So there's a default password that you can change. You log in, set in the default, the old favourite. So once I log in, you'll notice the little main menu button goes on, just to know that you're logged in. So let's go back to the main menu. So this alarm button will tell you when there's something wrong. So let's disconnect the bus. And also what you notice, there's an expansion bus flag up the top there. So if we disconnect the bus, it will do diagnostics, and in a second it will realise that it's not talking to that expansion module. And there it goes, the flag up the top goes an exclamation mark, and the little alarm key down, LED down there flashes, which we press on, and it will go one or more connected expansions not connected, so expansion 1 is disconnected. So let's pop that back. Okay, so that alarm should clear in a second. Let's go back to the main menu. Now also, as we say, there's a BMS watchdog program. So if we now drop the BMS, let's just see what happens there. So in a few seconds, I think I've set it to 5 seconds, it will realise it's not talking to BMS. It goes to exclamation mark. Now if we go into the IO readings, you notice there it gave me the option of the local or the expansion. I'm going to concentrate on the local. Now, if we look here, there's on 9 and 10, they're set for a watchdog function, and the little flag comes up to show you that indeed the watchdog function has kicked in and has set it to 1 to 100%, 1 to 0%. Okay, so let's put the BMS back in, give it a little while to clear. If we go back to the main menu, we'll see that flag clear. All right, so let's have a look at the IO readings menu. So we select local, this is a local one, this is an expansion one. So what you notice here is I've got UI set up as 10K3A1. I could warm that up, and what you notice is it responds very quickly actually. I've got a U2 set up as a digital input, it's just on or off. U3 I've set up as pulse count, just put a few pulses into there and it will count up, so on and so forth. If we go down, what you notice is in brackets against each universal I/O point, it tells you if it's input or output, so that's quite handy just to tell you what the function is. And there's U9. Now we can put things into manual. If we go back to the main menu, there's also manual section here. We go to the local. Now I could drop down to the say 9. That'll be fine. So I'll select that. Oops, sorry. Change that. Set it to 100. And then if we go back now to our IO readings, if we go down there now, what you'll notice is a flag that says you're in manual. Okay, so it's a good way of alerting people that things are not in automatic when they're doing servicing and checking faults and things like that. So let's have a look at the configure IO menu. So like I say, there is a web configurator that's a much better way of doing this, much more convenient, but you can do it from here. So you go through each channel, you can see what I've set up here. You can see that first one's a 10K3A1 for Mr. Input temperature sensor. Next one's digital input, pulse input, and if we go further down to channels 9 and 10, I've set those up for output, so you can set it from here if you like. So what you've also got on this module is some handy little functions. Now what these are like very basic control functions. So you've got 2 of each, so you could set one to be a pulse counter, which I've already set up. So there's only 2 of those. You could do an analog input rescale, so that what that will do is take a 0 to 10 volt and it will convert it to a 0 to 10 volt on 1 or up to 3 actually of the outputs that you can set down the bottom here. Okay, so there's 2 of those. There's a dig in to dig out, so that's just basically a digital input being mapped through to up to 3 digital outputs, and you can reverse it, so when the digital input is on, it can be direct and the digital outputs will be on, or it could be indirect and the digital outputs will be off, however you want to set that up. So it's very basic, but it just gives you a little bit of local control, which could be handy for say, sort of life safety things, like you've got some sort of fire strategy in here. It doesn't rely on the BMS carrying, or it can be done at a very low level down here to ensure that you know, there's a minimal amount of things in the chain to do life safety things like that. Maybe that's an idea for you. Okay, there's a T-stat. So yeah, this is basic sort of thermostat action. So as you can see here, you set a set point and hysteresis so it doesn't short cycle, and you can map this to up to 3 digital outputs and select, you know, like I could select that temperature sensor on universal input 1, and that could be used to control up to 3 digital outputs. 2 of those as well. Let's have a little look at the network settings. So you could say if the watchdog action is active or not, how much time it takes to kick in. You could have an offline watchdog as well. So this is basically looking to see if this link fails in any way. This will set its outputs accordingly as well. So that's another little feature there to sort of give you more resilience. Basic Modbus settings and things like that. Now the IP port, you can set up a static or DHCP, and this is where you put the settings for that as well. So one thing to say about the when you're looking at the I/O readings, you saw these little flags here. So there's actually a priority of how the outputs, I should say, rather than the inputs. There's a priority to how the outputs are set. You can see this one says manual at the moment. If there's nothing on it, automatic BMS control is being implemented. But the hierarchy is at the bottom of the priority is a BMS. If the watchdog function kicks in because the BMS isn't communicating, then that will take priority over BMS. Then if you've got any functions, like I say, life safety things, like say, you know, you want to look at a fire alarm input and position some smoke dampers or something like that, that will take priority over the watchdog, because the function can still control. If it can see the input, read the input, it can still work. And then after that, the manual will trump everything, and that will take priority. So you've got to consider that when you're creating your strategy, especially in sort of critical life safety scenarios. Okay, so let's look at the general settings, see what we've got in here. So basically, this is where you would set the number of connected outputs. I've only got 1, but if you've got like 2, 3, 4, up to 10, whatever, this is where you set that there so it knows how many to read. Also here, you can set whether you're using degrees C or Fahrenheit. And how many times you save the counters. Obviously, when you're pulse counting, if the unit was to go offline and you'd lose data, that might be quite important to you, depending on how important that is. This is how often or how low you need to set this setting. Right, so there's a little note there that says check the manual for more information about the flash memory. So obviously, the lower you set this, the more you're going to write and where the flash memory at. So you do need to take that into consideration. And there's a display buzzer, feedback beeping at every button press. I've set it to no because I find that annoying. It's up to you how you set that. And here's where you change the password. So here we have a place where you can restore data. Remember that we said you could plug a USB into here. And you can basically restore data onto here, or you can export data onto the USB stick from here. And also there's factory reset here. There's some details here as well. If you need tech support from us or you just want to know what version of software you're running, we do periodic updates to do bug fixes and maybe add features and things like that. So here you can see what version you're running, and there's some UID information, some sort of like tech support information that you could give us if you're having problems with the module. We can have a little look at the cycle time here and check what the actual unit is that we shipped, and get some information from you there that might help us out to identify faults. Right, so that explains the keypad. Now we're going to go online now and show you the web configurator. Okay, let's have a look at how we can use the web configurator to set up our IO20 and IO16 expansion module. So all you need to do is head on over to our website. If you go under products and you go to link IO, then scroll down, click on the link IO20, which you should recognise by now, and then you scroll down a little bit, and there's use our web configurator there, and you click on that. Now the first thing you're going to see is it's asking you, do you want to load an existing config or start from scratch? It might be you've got a colleague who's already set up an IO20 in a panel that's very similar to a project you're doing, which will be a good starting point. You could load that in and it'll have all the settings your colleague made, and you could tweak it, delete things, add things, do what you like. But we're going to start from scratch. So your first setting here, your first screen rather, you can see there's a different set of screens up here on these tabs here. So it jumps you into general settings. This is where you set up how many expansion modules there are. So I would set one there for my project. You can change the password and go through all those settings that we saw a lot of on the keypad. But it's just a more convenient way to do it here, as I'm sure you agree. Now, just to say about settings that don't apply, say you've bought an IP module, and the IP modules do Modbus and BACnet, by the way. You've got a lot of RS485 settings here which don't apply. You don't have to worry about them deleting them, just ignore them. They will not get loaded in, they won't mess things up for you. So if you had an Ethernet version, you just want to set the ports up down here on this particular page. You can't set the IP address up here, that's something you need to do on the keypad. So once you set all your general settings up, then you can click on your IO tab or screen, and you see at the top here, each module has a setting screen. So we've got two, haven't we? We've got the local, which means the IO20, which you must have on every system, and I've got one expansion module, so I'd just be dealing with these screens. You don't have to worry about the rest, they just get ignored if they don't apply. So what have we got here? So on the universal channels, you can set up input or output. If you change it to an output, the types change obviously to the output specific types. When it's input, you've got a range of different thermistor type sensors, or active 0 to 10, 4 to 20 milliamp, or if you want it to be pulse count, digital input, all that kind of thing is catered for there. There's also a selection here for filter speed. This is context sensitive. With an analog input, you might want to filter it if it's say a static pressure in a duct or something. You might want to do more filtering on that and increase that number there. So it gives you some options there. So there's some other settings here which are context sensitive. If, for example, we change the output, then you've got some settings here for the watchdog functionality there. So it's all context sensitive. Going down a little bit further, there's the digital outputs. They are just digital outputs, that's all they are, they're on or off. But you can set your watchdog settings here as well. And the manual settings you'll notice down in this column here as well for the outputs. You might want to preset manual settings to give the file to a panel maker and make sure everything's energized so you can prove the relays are coming in properly and things like that. It might save some time. You might want to do that on the pre-commissioning or panel testing stage of your project. So, yeah, the analog output, same as the universal channels here when set to output. You will notice that the two dedicated digital inputs, they have no settings. That's because there is nothing to set. They are dedicated digital inputs. That's all they do. So in case you were wondering why they're not there, that's why there's nothing to set. So once you've dealt with all your local IO20s or your expansion IO16 modules, if you want to set any functions up, like we said, you might have counter on the digital inputs or universal inputs. You might want to set those for counter function. You've got two of those that you can set. Or you might want to do some on-board control, like we said, for life safety or something like that, with a fire alarm, maybe positioning smoke dampers or something like that. So here's where you set all that up. We won't go through everything, but you can see here, you know, I could set digital input 1 to fire, digital output 1 to 3 if I wanted to do that. We could set that up like that to do that, and we could just make it reverse or direct depending on what you want to do. There's two of each, as you'll see, two of each function. So we won't go through it like I say, but the manual tells you how to set these up, what all the different parameters mean. But there's just a convenient way to do this in the comfort of your desk without sticking your head in a panel and using a little keypad. So I think you agree it's a much better way of doing things. So when you've finished setting all your different configuration settings and parameters up, you can click download config, and down in the bottom left here we can see there's a little file, that text file that gets spat out that you can take and email to a colleague, or say a commissioning engineer who's going to commission the job for you, or you might want to put it on a memory stick yourself and put it into your IO20 and download it into there to configure the unit. Well, I hope you found that interesting. If you'd like to learn a bit more, head on over to our website where you can find the data sheets and manuals. And also you might want to look at our knowledge base where there's some specific things about Link.io and more sort of related things like Modbus and BACnet. So I hope you enjoyed that. Thanks for watching, and see you in the next video.